Okay, so this problem reads, the propeller of a World War II fighter plane is 2.3 meters in diameter. What's its angular velocity in radians per second if it spins at 1200 revolutions per minute? What's the linear speed of the tip of the propeller if the plane is stationary on the tarmac? And what's the centripetal acceleration of the propeller tip under these conditions in meters per second squared and as a ratio of g's? So we know that the diameter of the propeller is equal to 2.30 meters. We're going to need radius. So we also want to recognize that the radius of the propeller is equal to 1.15 meters. All right. Part A. Part A says, remember, that what's the angular velocity in radians per second if it spins at 1200 revolutions per minute? So we want to start with 1200 revolutions per minute and turn it into radians per second. So we know in 1 minute we have 60 seconds. That's going to get our seconds on the bottom. And we know for 1 revolution we have 2 pi radians. So our radians per second is 126 radians per second. Perfect. So that's part A. And part B says, what's the linear speed at a tip at this angular velocity? So rotating at this angular velocity, what's the linear speed? We know that the linear speed is equal to the radius times the angular velocity. So we just need to take the radius of 1.15 times our angular velocity of 126, and we get 145 meters per second is its linear speed at the tip. Part C asks us, what's the angular acceleration, the centripetal acceleration? The centripetal acceleration, remember, is the linear speed squared over the radius. It's also omega squared times the radius, so we could use either one. But I just figured out that linear speed, so we'll use that one. The linear speed is 145 squared over our radius of 1.15. That gives us a centripetal acceleration of 183 times 10 to the 4th meters per second squared. And it also wants us to determine, 1.83. 1.83 times 10 to the 4th. 183 times 10 to the 4th would be pretty big. 1.83 times 10 to the 4th. And that is about 1,800 G's. So pretty intense there at the end of that propeller. All right, so converting my revolutions per minute to radians per second, determining that linear speed at the tip at that radius of 1.15 meters, and then using that to figure out our centripetal acceleration. Good job.